electric fence energizer is going to be rated in what?
Joules.
Joules, not miles, or any other stupid nomenclature. Okay, so joules are what electric energizers should be rated in. That's just a unit of energy, and it's actually a very tiny unit of energy. Okay, just as an example, I like this example. If you take a pound of 32-degree ice and you turn it into 32-degree water, so you didn't raise the temperature at all. All you did was take it through the phase change from ice to water. About how many joules do you think that takes? 100,000. That's how many joules it takes to turn a pound of 32-degree ice into a pound of 32-degree water. You just living is about, your body is producing about 1,000 joules per second of heat energy. A joule is a very small amount of energy. Now, the reason why, if you can go to a 1 joule fence and you touch it in the wrong way and it shocks the fire out of you, the reason is it's because it's giving you that 1 joule as fast as a bolt of lightning. So it just took that energy and turned it into power. So power is energy divided by time. So lightning's really fast, and it'll jump in about 100 millionth of a second, which is the power of roughly the space shuttle. Okay? And it hits you just real quick, so that's why it hurts. So it's really not dangerous at all, most of the time. Unless you get tangled up in a fence, and you fall down, and you no longer have your insulated boots insulating you from the ground, and you get shocked over and over and over and over again. So I'm always telling people with kids, you never let kids cross a poultry fence unsupervised, okay? If you're not very experienced, you might not want to do it yourself either. You need somebody to be able to run over there and unplug the fence, okay? So I got the safety thing out of the way. There you go. So electric fences, you can think of, like if you have just no concept of what's going on in there, you can absolutely 100% think of it as a pressurized water system. Okay, voltage can be modeled one-to-one with a water system. We did it I had friends that did it in college. Don't ask me what device they used to be capacitors. Fill up with water and we'll just say water balloons, how about that? Jeff's presentation, it was all about excellence and understanding what is going on inside your feed so that you can be a better farmer. The more industries we bring into farming, the more we tend to let things slack off, and then they don't work so good. So, it's this constant battle of trying to expand so we're not just doing eggs. Now we're doing eggs and broilers, and then we're going to expand to do chickens or cows. We're going to expand to do pigs, et cetera, et cetera. But you're always learning a brand new industry, and this is what some people do with their whole career. So we're learning all these careers, and it's easy to start letting things slip, and then they become unprofitable. So I wanted to go out there and observe what I had to look at, what I had to work with later at a paddock, and I found this wire at a certain farm earlier today. And I might be picking on some folks today, but don't worry, because I bet I can run faster than you.
I don't know about that either.
All right. So with any electric fence energizing system, it's only as strong as the weakest link. Okay? So what are some weak links in an electric fence energizer system? Call them out.
Grass.
What?
Grass.
Grass doing what?
Grounding.
Grass touching a hot fence and stealing energy. What else?
Gates.
Gates? Okay, we'll explain it.
Well, sometimes you get left on the ground and chewed up by the mower. It's in your hand.
Okay, so sometimes the gates.
But then there's just, the connections aren't always solid. We, just kind of
That is it.
break it and then rig it.
Connections. So connections don't always connect correctly.
The grounding system.
Grounding system. You can have the biggest energizer in the world. If it's not properly grounded, there is no place for that energy to get to after it goes through the animal.
Metal posts.
Man, you guys are hitting all of them. Good job. So a metal post. If a hot wire touches a metal post, which is going into the ground, you're losing electricity down there. All right, so from a broad overview, this is what happens. We have a fence energizer. We'll call it this screen right here. So this fence energizer stores up a bunch of energy, and it's just waiting to let it go. Okay? And then we're going to jumper from our fence energizer to a poultry electric net fence, and you're going to connect it to a connector, because this is a solid connection and it's squeezed real tight against every single one of these lines. You're not going to attach it to a single line. Why are we not going to do that?
The wire's too thin.
It's wire too thin. It's going to burn it out. Because now it's trying to get all this energy. It's trying to squeeze all this energy that's supposed to be going through like a 2-inch PVC line. If we want to use the water convention, we're trying to squeeze all that water through a little 1/4-inch hose. Okay, so we need to connect it to the big line so that it can easily distribute electricity to the whole fence. This fence needs to be set up nice and tight and not too saggy, because if it's too saggy, all of these little hot wires are touching little tiny pieces of grass. And each piece of grass is not drawing that much energy from the system, but if you add it up and you got 10,000 of them, all those draws are reducing the pressure of your system or your voltage. Pressure and voltage are the same thing. Okay? So if you reduce the voltage of your fence, it's the same thing as poking a bunch of holes in your garden hose. All the water's leaking out before it ever gets to where you need it to supply. Okay? So this fence, if it's properly set up, it's not touching the ground, it's all tight and insulated. The young man right there said metal posts. These fences work really good until you get to the ends. What happens on the last post, typically, of these chicken fences? Anybody know?
Hook them up to
Your bottom hot wire slips down off the insulated and touches the metal post. And the metal post is going straight into the ground. Okay? That's a hard thing to remember and to get your employees to remember. It's every corner, you just need to always be looking and see if that slipped down. A lot of people just chop that last line right there and just be done with it. That's probably a pretty good solution. Okay? So, if we don't have any leaks in the fence right now, once a second, this energizer is pulsing and it's opening a circuit, or it's closing a circuit, just for a second. And if there's a way for that electricity to get through our fence to the ground, usually through an animal or operator, then the electricity goes into the ground, makes its way all the way back to the negative side of your fence energizer. Your circuit's connected, and depending on your resistance, you used up you generated a certain amount of current, and it hurt. All right. Now the good thing about humans is we're usually wearing rubber shoes, rubber boots of some sort. Okay, so who here goes and tests their electric fences with their hands? Okay, we got a few people testing it. Hey, all right.
Well, my hand via a blade of grass.
Hand via a blade of grass, okay? We're going to show you ways to do that out there that doesn't hurt.
Never really hurts when I use the grass.
Oh, that takes too long.
Yes.
As long as you have your boots on.
As long as you have your
off, you get the socks in the wet grass, then you're on your knees.
Yeah. Are there any questions so far?
Well, just on that, we've got, I can think of 4 or 5 employees a lot that can touch the fence no matter yet. And they touch it like this. And I kind of learned that that's their blood type. And you say no. Why not? What is it?
Okay, so this is, oh man, this is a hilarious story. I had this buddy in college who was like way louder than me. He was a short little dude in the army. He was hilarious. He came out to our farm and he's like, "Oh, electric fence. This used to hurt when I was a kid." And he goes up there. I'm like, "Oh, this is going to be so great. I have a 24-joule energizer. Somebody get a camera." And he puts his hand on it. I'm like, "All right." And then he grabs it. I'm like, "Fence not working?" What in the world? I was like, did the Army train him? Like, what kind of boots are you wearing? I was so disappointed. Well, and then I've been doing this for 10 years and I figured it out. Okay. The components inside the Energizer, they close for once, the little switch closes for once a second for a pretty short period of time. 1/10,000th of a second, I think. But electricity flows much faster than that. Okay? But that switch, you know, it has some time it has to close. It has to ramp up its electricity and everything. So if you just grab the fence, it doesn't transfer it to you in a lightning bolt anymore. A lightning bolt moves at will transfer energy at 100 millionth of a second. That's a fairly lot amount of energy for that small period of time, and it hurts like fire. But so my fence is right here. If I put my finger a quarter inch away, that lightning is going to jump and it's going to hurt. If I just grab it, it has all the time in the world to ramp up and then ramp back down. Remember, your body is burning 1,000 joules a second just to operate, and you run off electricity. That's all it is, electricity. So if you just grab it, it doesn't hurt. Now, if you connect a circuit, you grab a hot line and electric and a fence that's laying on the ground, you're going to be able to taste it. And you might forget you're in California.
Right. I got a stumper for you. All right. So I have I've had a lot of young people come and work for us, and you know, we generally make net into a circle.
Yeah.
And I had one young guy who said, "Well, wait a minute," because I said we got to make sure our connections are all right, and then we're gonna the fence is off, and we'll connect it to the fence, and we just have to make sure those are all secure. And he said, "But wait a minute, if it runs in a circle, doesn't that cancel it out?" And I wanted to know how you would explain it to him.
Yeah, this is electric fence 303.
303.
Glass right here.
Yeah.
And that's actually one of the draws of, this is one of the leaks in your system is induction. All right. So everybody knows how electric motor works, right?
No.
Okay. If you pass voltage through a line, a hot line, any kind, it generates a magnetic field, and it's called the right-hand rule. You put your thumb in the direction that the voltage is flowing that way. Whichever way your hand curls, your fingers curl, it's generating an electric field that way. It never goes left-hand. Even works in outer space. And scientists have no clue why. It's the Holy Spirit.
Even at the South Pole?
Yeah.
Okay, check.
Everywhere. Yeah. I used to think it'd be the gravitation. No, it has nothing to do with that.
Yeah.
No, it's a law of nature until God changes it. But it's always right-hand rule. And so then, since it's generating this magnetic field around here, and the magnetic field varies with current and voltage and everything else, well, you can have a completely cold line right next to it, and that magnetic field encompasses this line too. So what do you think happens to this line that's not connected to anything? What happens when you put it closed? It'll have 1,000 volts on it.
Yeah.
It'll start generating, that's just called induction. And so these fences are by nature like 10 lines all together, and they're all inducing current into one another. But the problem is, if you have to, name your book, get this. Oh, yeah. So here's, we're looking at a cross section of our wire right there and right there. So if our electricity is going into the board,
You just look at your back.
oh, anyway. So electricity is going into the board. We right hand rule it. Okay. So it's generating electric. A magnetic field that way. Well, this one's doing the same thing. And guess what happens to those magnetic fields? They run into each other. So poultry net fencing, this is 100 feet long, let's say. Let's say there's 10 lines. There's 1,000 linear feet of electric fence in this electric fence. But this will reduce, whenever you hook this up to an electric fence energizer, it's going to bring down the voltage way more than a regular old 1,000-foot cow line made out of the same material.
Right.
And the reason is because those currents or those magnetic fields are all running into each other. And so, same thing, if you're looking at you make a big cow fence right here. You got a bunch of cows in there, and you hook up your positive to this end, right? Voltage flows all the way around and you're good. If you take this end and tie it in there too, voltage is now going both directions, and it's trying to cancel itself. It's sort of like photons of light. Is it a particle or a wave? It's both. This is both too. So you would think that it would be absolutely 0 volts right there, but it's not. There's still some voltage, but it did start to cancel each other out. So like whenever you're doing cow fences, you don't want to run hot from both sides going around so it crashes on the other side. But poultry fencing, because we usually keep it in such bad disrepair, and there's lots of breaks anyway.
Yeah.
And because the whole system is crashing into each other anyway, it doesn't even matter. Connect the whole thing together and hopefully you still have voltage at the other side.
Nice.
Yeah, so if you're just running like a single line polywire, it's better to only energize from one side. If you're running poultry netting, connect it as many times as you can. But now, okay, so I'm just gonna add this right here. I like per 100 feet of poultry netting, I like half a joule of energy. So if I have 400 feet poultry netting, I would like a 2 joule charger. That's just me. You can go.
You'll see what we
A
have.
lot less sometimes. Hey,
But would there be percentage in leaving one connection undone, and then you have hot on one side that is one single line going out, and the other side, even though they're connected maybe with a shoelace in the middle, 2 posts are.
See, I honestly don't know the answer to that question, Bruce.
Gotcha.
But since a poultry netting has so many lines all interfering anyway, so we got magnetic field crashing every single time it does that. I don't think it's going to change anything. I don't think
Right.
if you connect it both ways. But what I do know is that a lot of my fences can't get voltage all the way around anyway, so you might as well try the other side too.
Yeah, there you go.
Yes, Roseanne.
That doesn't change much, like, I think it's still working. Can you go ahead to pause negative fence?
Yeah. So the posi negative, and Premier has it too.
Okay.
Okay, so and I think I might be part of the reason for that because I made a bad assumption and told them to do it. But the posi negative electric fences they run a number of, every other line, it goes hot, cold, hot, cold, hot, cold. And if you do it correctly, you take the colds and you actually ground them, or you attach them straight to the negative side of your fence energizer. And then it's like, so if an animal tries to stick its head through, you don't need the ground anymore. It's going straight from here to here. And that
And it's
chicken
grounded
gets
at
chicken.
Yeah.
Just for a minute.
It seems like that could ground itself out, really.
Well, they've actually I feel like they've done a pretty good job of keeping it from grounding itself out. They're using more stable uprights in between, like the little plastic dealios that tie everything together. They're making it a little stiffer. You have to take a little bit of care at the end of the fences, but it seems like it does good. I've used them. Yes, sir.
So when you just have a single strand of hot wire, where did the electrons go? If it doesn't grounds out on a calorie, then
Yeah.
you send out the electron.
Yeah, it actually didn't. So it stores it in the capacitor. So in other words, if you have a fence energizer that is charged and you can hear it clicking, but it's not actually shocking anything, you can put an amp, or you can measure your meter. Your meter's using way less energy than if it's shocking something every second, like it's grounded on a T-post or something. So your meter basically won't even turn when it's not shocking something, but when it is shocking something, it's using some energy. So it's constantly trying to charge that capacitor, but the capacitor can only let it go if there's a place for it to go.
So you're not actually it only sends out electrons if it finds a short.
Okay, so let's go back to the high pressure water system diagram again, right? So we have a pressure tank that's 100 psi, and it's hooked up to 1-inch PVC that goes a mile. Okay, we're 100 psi, and we take the valve and we turn it on and off because we're pulsing. On up, on up. Where'd the water go?
Nowhere,
Nowhere.
because there's no leak.
Just because there's no leak.
Right.
So it's that first pulse, when it clicks for the very first time you turn it on, it basically charges the line.
It's charging the capacitor.
Gotcha.
Yeah, it's charging the capacitor. Great.
And that's why he's my friend.
But it's nearly impossible to set up a fence that isn't somehow even at least slightly grounded.
Yeah, you're always gonna have leaks.
At least we always have little leaks.
Yeah, and we're always gonna have leaks. Okay, so weak links. We said. Did anybody say the size of the Energizer? So the size of the Energizer, you can buy Energizers that are itty bitty tiny that charge 500 feet of fence. You can buy ones, like I said, that they use on Jurassic Park. Okay, they can keep elephants in literally. Okay, but most of the time when somebody's fence is not working, they think I need a bigger Energizer. You probably don't. You probably just need to clean up your act. Okay, so there's power. There's oxidation. Okay, so I got this wire from somewhere. Earlier today, and so I'm going to pass it around. I'll start with Christian. But the end here is really oxidized, okay? Oxidation does not transfer electricity. Oxidation is rust, aluminum oxide, copper oxide, iron oxide, anything. Unless you build your fences out of gold, the stuff's going to oxidize. Okay, so we have an example of a very oxidized fence. If you need to connect your fences together, don't ever use wire ties, twist ties, wire nuts, unless you electrical tape the snot out of them, and you got to do it right. Electrical taping must be done right to keep oxygen and water out. Like we did. No, this is mine. This is what I was doing back then. Also, you probably would not want to use 600 volt wire or wire rated to 600 volts. I mean, it's okay. I'd probably do it. But it's not going to last that long, and it doesn't really insulate as much as it could. Okay, you lay this on the ground, it's going to start shocking through it to the ground. You can see it at night. If you take a wire like this, you buy at the hardware store, and you lay it on the ground on a damp night, you come out there, you'll see these little sparks all over the place. Ask me how I know that. But anyway, this is how to really well connect two wires together. You take the unbraided ends apart. You unfold each end. You twist these two together, and then you twist the whole bundle together. So I'm just going to pass it around, and you can look. Here's the first step. Here's the second step. Here's the third step. This wire is really old, and I just stripped the end of it and pulled it apart. You can see the nasty dark oxidation in there. The whole wire will oxidize. I think it's galvanic effect on it. Anyway, pass that around. You need everything nice and clean. So what I did was I cleaned up Christian's act out there, and I doubled the voltage this morning.
On all tubes?
No, I'm sure what happened was he parked the junkiest one right here just so I would do that.
Matt, are you using dielectric based on your connections to prevent some of that?
No, I usually don't. Now, I will say one thing. No matter what you're using electrical tape for, if you buy anything but 3M Super 33, you might as well just stop parking. The Super 33 electrical tape, I mean, it's like the only stuff that lasts. It's really high quality, and you buy it anywhere. You buy it at Lowe's, you can buy it at Elliott Electric. If you go to a cheap hardware store, or Lowe's for that matter, you buy the cheap electrical tape, I should think of a good analogy right now, but it's not good. Right? It's like buying Vital Farm tape. Right? Loose connections, tighten up all your connections. Surface area. Who said surface area? You sort of said it. You know, your connection, whenever your handles come together to connect, if you don't have a good surface area, you're not transferring enough electricity because it just plain out can't do it. Can you hold your board up again? Thank you. So, have you ever like taken one of those magnets, a horseshoe magnet, and then you put like a bunch of iron down there and it forms a pattern? Have you ever seen that? Anybody? It's like, it forms a pattern like this.
Flux lines.
Ooh, fancy, I'll have to use that next time. The Earth does the same thing, right?
Yep.
I mean, yeah. This is trying to find the path of least resistance, okay, to get the positives to the negatives. And so it uses many different paths. Same thing happens when electricity is trying to flow anywhere, but especially through the ground to get home again. Once you get shocked, or your animal gets shocked, that electricity has to have a good path to get home, or you're not getting your full potential voltage. That was an electrical joke.
Well landed. Well landed.
Yeah. That really hit home.
Potential is voltage. Okay. So, whenever, how many, okay, so grounding rods, very important. Somebody said that, Dave, is that you? How many linear feet of ground rod need to be shoved into the ground for each joule of energy on an electric fence? Is there a standard?
It depends.
It does depend. Give me a rule of thumb, a generalization. So big power lines that go up above your head and everything, there's at least a positive and a negative in there. And every single negative at every single pole, and I'm talking like real electricity, you know, like coming from the power company, every single pole, there's a copper wire that grabs a negative and goes and shoves into the ground 6 feet. Every single pole.
Every single pole.
Every single pole. And so what that means is whenever you use electricity with your blender and it goes back into the negative, it's going through, I mean, it's taken millions of paths to get back to the power plant. Taking millions of paths because it's going, a little tiny bit's going through every single ground and every single pole all the way back there. And once it hits the ground, it does this. It spreads out underground like a spider web. Okay? And that's why you need lots of grounding rods. Because the ground is conductive, but it's not that conductive. And so you need a lot of surface area. Y'all falling asleep? It's exciting. Shocking. But you need a lot of grounding rods to grab as much surface area underground as you can so that electricity can flow easily back to home base.
How many feet?
Okay, it's about 3, I've read about 3 feet per joule. Okay, so if you have a 24 joule charger like me, I need about 75 feet of grounding rods stuck underground. They're each 6 feet long. I need about, 12 or so? 12 big old grounding rods. And they're not close together. You want to space them out because this patch of ground might not conduct electricity very good during a dry month. And this one does because of the iron ore. And that one's on a good drip edge. So when it rains, that one helps.
Yeah.
And there's lots of resources online. You can go read about this, I mean, it's very riveting.
And for us, we try a mile of copper wire.
What's that?
We tried a mile of copper wire buried in a huge hole, and that didn't work.
Whoa.
It wasn't a mile. It was a little less than a mile.
Okay. All right. Yeah, another one's people.
When the ground is irrigated and damp and has green grass growing, is that number less?
Oh yeah. Yeah. Better. In general, the moisture, the soil, the better the conductivity. A lot has to do with your salts and minerals in the soil. I mean, you just have to try.
We use chain link fence on the ground. Feet of chain link fence.
Okay. Yeah, there's lots of ways to the ground.
Instead of having hoses and pole.
All right. But the more you understand this, the better you see problems as you go, and you can just fix them when you're out there. Okay, has anybody seen one of these? Who does not know what this is? Nobody wants to admit it. Okay, there's a fence energizer tester. This is a pretty nice one. I like this kind. This will measure your voltage of anywhere you're at in the fence, and it'll measure the current, and the current is related to how much energy is being used by shocking something past you. But it doesn't know what happened between you and the energizer. So you could have a terrible, like Christian could be dead on the fence right here, shocking himself all to pieces, and the energizer's over there, and if I measure the fence here, I don't know about it. All I know is I only got 1,000 volts. That's because he's absorbing it all. So your amps just tell you what's going on past where you're at. So if you measure at home base, okay, here's home base. You know, this wire is going to power a bunch of fences. If I measure right here, I'd have to cut the sheathing off first. But then I'd be able to measure right here, and it would tell me both the voltage of my fence. Voltage is how able that fence is to shock something. So if you don't have high voltage, you have no potential to shock anything. So it'll tell me my voltage, but it'll also tell me how many amps I've got, which means, am I shocking something right now? You guys want to go out and play?
Yeah.
We'll go do some real life experience. Hey,